Mrs. Marlene Lord Lewis, President of NIHERST, Dr. Chris Mirage, President of APETT, Mr. Craig Boodoo, Senior Energy Analyst and Head of Renewable Energy Division at the Ministry of Energy and Energy Industries, Dr. Indra Harak Singh, Lecturer of Physics at UWI and Renewable Energy Specialist, Mr. Graham Jones, Director and Co-Founder of Rescott Limited, members of the NIHERST and APETT team, engineers, business professionals, educators, ladies and gentlemen, good evening. My name is Kamal Georges, and I have the distinct honor of being your moderator for this evening. Welcome to our webinar, Finding Solutions to Engineering Challenges, Session 3, and we're focusing on sustainable energy. This is a partnered initiative between the National Institute for Higher Education, Research, Science and Technology, NIHERST, and the Association of Professional Engineers of Trinidad and Tobago, APETT. To ensure we reach as many people as possible, this evening's session is being live streamed on APETT and NIHERST's Facebook pages, as well as on YouTube. Now, energy has been in the spotlight over the last few days, and therefore this discussion, it is extremely timely, more so with the heightened topic of climate change and its impact on society. The subject of sustainable energy, with its specific role in achieving global sustainable development goals, has been brought to the forefront. And in response to this, the authorities at the collaborating institutes here saw it wise to produce a forum where proven information can be provided and points of view discussed to progress towards workable solutions, extremely important, solutions to alleviate the societal pain points relating to this particular subject. As a visionary in environmental transformation via scientific, technological, and innovative solutions, we begin with a presentation focusing on the collaboration and the critical role of new age technology and scientific reasoning in sustainable energy. Take a look.
As the leader in science, technology, and innovation, NIHERST, we are pleased to partner with APETT on today's webinar, Finding Solutions to Engineering Challenges. As we work together towards this common goal, it is clear that we have begun to chart the course towards realizing tangible results. How did this collaboration come to the fore, you may ask? The synergy is clear between what we do at NIHERST and APETT. NIHERST, a statutory body currently under the Ministry of Education, was incorporated in 1984 to promote the development of science, technology, and higher education in Trinidad and Tobago, and enhance the innovative, creative, and entrepreneurial capabilities of the general population. Likewise, APETT, through its professional body of engineers, strives to stimulate awareness of technology and the role of the engineer in society. Both parties are indeed committed to future-proofing our nation. But how do we do this? At NIHERST, this is effected primarily through research and policy development, conducting statistical surveys for decision-making, digital fabrication and prototyping, and STEM, science, technology, engineering, and math integration. Notably, this core offering of STEM integration further highlights the linkage between NIHERST and APETT. STEM places emphasis on innovation, problem solving, and critical thinking, and together they make up a popular and fast-growing industry. But one may ask, how is engineering important in STEM? STEM is an integrated approach to learning. Engineering is what connects the disciplines. Engineers seek solutions to problems, then apply scientific knowledge and mathematics to design, build, and maintain technologies to solve the problems. STEM is necessary for growing the economy and staying globally competitive. More and more, we see the synergy emerging. This partnership between NIHERST and APETT has been sealed by a memorandum of cooperation with projects to include an Engineering Icons video series, a feasibility study to establish a mentorship internship program sourced from the APETT database, and this, our tripartite public seminar series that addresses engineering challenges or societal pain points. As we are aware, today's session will focus on sustainable energy. Though the topic of sustainable energy has risen to the top of the agenda at many assemblies, there is a need for greater implementation. Our reliance on oil and gas extraction can lead to air and water pollution, land degradation, and dirty emissions that drive climate change. Notably, the burning of fossil fuel is indeed a major factor in the long-term shifting of temperatures and weather patterns. According to the National Oceanographic Atmospheric Administration, NOAA, global temperatures have risen by 0.08 degrees Celsius per decade since 1880, but the rate of warming since 1981 is more than twice that at 0.18 degrees Celsius per decade. Additionally, the year 2021 was the sixth warmest year on record based on NOAA's temperature data. Average across land and ocean, the 2021 surface temperature was 0.84 degrees Celsius warmer than the 20th century average of 13.9 degrees Celsius and 1.04 degrees Celsius warmer than the pre-industrial period between 1880 and 1900. This gradual and alarming change in the climate should not be taken lightly. It must be maintained that such changes can have a domino effect on its surrounding ecosystems. As such, there is a need for rapid adoption of sustainable energy streams as our reliance on fossil fuels are growing more expensive and less accessible. Timely integration of sustainable energy sources will help to conserve the planet's natural resources and reduce pollution. Once implemented, communities will be able to benefit from a clean, safe, and efficient energy source, along with the added advantages of improved public health, job generation, and the increase in the country's GDP, as well as a sense of energy security. While there's a need for much input from corporate communities, we as individuals must do our part in reducing our carbon footprint. As it stands, the road towards 100% reliance on sustainable energy is no easy challenge. Ahead of its implementation, its advocates will be faced with issues of cost, infrastructural challenges, and policy complications. However, like with all advancements, the full potential of its efficient and effective workings can only be observed upon the completion of the necessary quality checkpoints and procedural obligations. At this webinar, it is our hope that the information provided and the conversation generated will help spark the creativity required to conceive such innovations, to advance such innovations, and to alleviate our concentration on fossil fuel energy in various communities. More so, our intention is to encourage those represented here today to adopt responsible best practices as it relates to the consumption of fossil fuel energy, engage in conversations within their networks to further sustainable energy implementation, respond adequately to the effects of the growing threat of climate change, promote healthy discourse that would lead to proper policy formulation and adoption on the matter, and to promote strategic measures to educate the general public on sustainable energy and the preservation of our green environment. Remember, we are all in this together. Let's work collectively to make our nation a better place for all.
A really informative presentation there to get us going this evening and putting into context the discussion that we'll be having throughout this evening. We certainly admire your continued contributions to progressing the nation's strides in being a climate conscious and an environmentally friendly society. We do have a lot of work to do. Participants, please remember to place your comments in the chat box and we will respond in our Q&A segment a little later on. Now, some of you have already submitted questions and we certainly are looking forward to engaging with you a little later and advancing the discussion. At this point, it is my pleasure to introduce our first panelist of the evening, Dr. Harak Singh. She is a lecturer in physics at the University of the West Indies St. Augustine campus. Dr. Harak Singh holds a PhD in physics in solar energy, a diploma in education, and a BSc in both physics and mathematics. She is credited with developing the UE MSc Renewable Energy Technology Program, and she currently sits as the president of the Caribbean Solar Energy Society. She is also part of numerous influential committees, including the Steering Committee of the World Renewable Network and Project Steering Committee at the CARICOM-appointed Caribbean Renewable Energy Development Program, and also the IDB-funded Bridge Renewable Energy Projects. Dr. Harak Singh is one of the key people involved in training and capacity building in renewable energy in the Caribbean region. Dr. Harak Singh, good evening, and it's a pleasure to have you here with us.
Thank you very much, Kamal. Good evening, everyone. And first, I wish to congratulate NIHERST and APETT for their foresight in organizing this webinar, which is extremely important given the climate change challenges, and it's also very, very timely. So,
couldn't agree with you more. So,
yeah.
Dr. Harak Singh, we wanted to start off our discussion this evening by asking you, what are the renewable technologies that are available and would be most applicable, appropriate, or easily adopted here in Trinidad and Tobago?
Thank you. That question is loaded. It has a lot of dynamics in it. And first, I would start by saying that our main goal is increased sustainability. And how are we going to achieve this? And this is where I bring in the concept of renewable energy technologies. We definitely need to have an increased utilization of renewable energy, and we need to look at the social and environmental impacts, the technical aspects, economic aspects for sure, and commercialization. There's no point in us having it when we cannot have it commercially available. We need to look at research and development, innovation, incentive programs, and of course, training and capacity building. So what is this term we call renewable energy? So renewable energy technologies really is an overarching term, an umbrella term that's used to encompass energy production using renewable energy sources. These are sources like solar, coming from the sun, wind, coming from the uneven heating of the land and the sea. The water technologies like hydro, tidal, and wave, biomass, biofuels, and waste, fuel cells, and geothermal energy, which is extremely important for most of the Lesser Antilles because of how these islands were formed by the subduction of the North Atlantic plate going under the Caribbean plate. Magma was ejected up, and this magma is really what is the basis of the formation of these islands. And this is what makes geothermal energy so important and so rich for the Lesser Antilles. We also have carbon capture and storage, and we are focusing on hydrogen technology, hydrogen energy, and we are hoping to make this a big success here in Trinidad and Tobago. But renewable energy resources and technologies are definitely a key component of sustainable energy development for several reasons. One of these is they have less environmental impact than the other energy sources. And because we have a variety of these renewable energy resources, there is a flexible array of options for their use. They also cannot be depleted, and they can provide a reliable and sustainable supply of energy almost indefinitely, in contrast to fossil fuel and uranium resources. They favor system decentralization and local solutions that are somewhat independent of the national network. And this makes it a very flexible system and provides economic benefits to small island isolated populations. The great adaptability in responding to unpredictable growth and changes is definitely a big plus. So there are many, but this doesn't come so easily. There are many challenges, many challenges, but I want to focus at this point on one of the biggest problems, the financial aspects. So financial aspects deal with why is it so difficult? Now, there's a very high risk perception by financial institutions, and this is one of the reasons that access to finance is an issue. Project finance is also not available for renewable energy projects, and risk mitigation instruments such as guarantees and so are not easily available. There are high upfront costs, and a high cost of finance can also make the projects not viable. So in the case of utility scale projects, grid strengthening is a major issue and will require substantial investment. which distribution companies may find difficult to raise, particularly in developing countries. Also, one of the challenges is challenges or pluses, depending on what your country's resources are and what's your country's agenda. Nonetheless, with all the challenges, there are many opportunities which can be gained from moving towards renewable energy technologies. And these renewable energy technologies are developing progressively with increased efficiency. There's a growing demand and the depleting fossil fuel, which allow renewable energy to flourish. Renewable energy systems can be installed at small levels, and this makes it very good for small island states, for small off-grid systems. There are some areas which cannot be easily electrified by the local grid. Renewable energy systems are also very socially and economically accepted by the people. But the big plus is the possibility of job creation increases significantly. So in closing, I just want to say that by investing in renewable energy, research and development, renewable energy technologies, and the balance of system can be made cheap, and that will help to achieve grid parity. All of these are opportunities, and these opportunities can lead to increased sustainability. And we'll talk more a bit later. Thank you.
All right, Dr. Harak Singh, thank you very much. We certainly will be talking a lot more a little later on, especially in our Q&A segment. Thank you very much for sharing your wealth of knowledge with us, at least giving us a taste. And we look forward to hearing more from you a little later.
Yeah.
Now, in our drive to promote a healthy, sustainable energy standard, insights from the private sector community is always welcome. And we understand that this topic poses a series of questions to all, some of which must be answered by those within the business fraternity. And in light of this, we welcome to the spotlight Mr. Graham Jones. A little bit about him. After graduating with a BSc in engineering, Mr. Jones started his career in the downstream energy sector before entering the upstream. Working on a drilling rig as a field engineer, he developed a love for the energy sector and wanted to make an impact, as so many of us do. So while studying for an MSc in Commercial Renewable Energy Development and Climate Change in the UK, Rescott Limited was born. The idea was to create an engineering-based company that adhered to engineering codes and standards to restore confidence in renewable energy and drive decarbonization efforts in Trinidad and Tobago, but also the wider Caribbean region. 7 years later, Rescott Limited has grown tremendously. It is now ISO 9001 certified. It has helped implement over 100 megawatts of renewable energy internationally, which significantly contributes to our country's energy sustainability, NDCs, and also a carbon-free future. Graham, welcome.
Thank you very much for that introduction, Kamal, and welcome to all our viewers, and happy to add my 2 cents on this webinar. Thank you.
Right. Thank you. Thank you for being here. So Dr. Harak Singh put some really great context on the conversation this evening from a broader perspective. And so we wanted to go a little narrower. What are some examples of how industries and homes can incorporate renewables and energy efficiency to make their operations more energy resilient?
All right. So firstly, I'd like to thank Dr. Harak Singh for laying that robust foundation, again, from which I could add my 2 cents on this question. You heard Dr. Harak Singh talk about technologies, renewable energy schemes. We heard her talk about the advantages, the red tape, the disadvantages, the pros, cons, etc., as it relates to the renewable energy sector, the hydrogen economy, even I heard that being mentioned. But I'm going to kind of narrow in my focus on what our core business is at Rescott Limited, which is solar energy. And as a company having more than 100 megawatts, in excess of 100 megawatts of solar energy experience, we've seen the application of renewables in a broad, wide range variety of industries. Inter alia, some of them might include cold storage, some might include petrochemical facilities, manufacturing, greenhouses, the application of agrivoltaics, and even in data centers and Bitcoin mining, we've seen some applications. So I'm going to touch on commercial and industrial applications. So for these categories, in preparation for a more than 100% increase in the cost of electrical utilities, as we've been seeing in recent articles and consultations with the RIC, Regulated Industries Commission, we need engineering solutions. Engineering solutions are required to resolve complex energy issues and significantly offset energy consumption. And we need financing, as you heard Dr. Harak Singh mention again. So I'll say whenever we engage an energy intensive client, our first premise is to uncover those methods of energy reduction by way of energy audits, by way of carbon audits, and we do this using certified professionals, certified energy managers, certified carbon accountants, and we do this under the Trinidad and Tobago Association of Energy Engineers, which is a local chapter for AEE. And we do this using a bunch of other international consultants as well. So with these quick wins for those clients, we could justify further payback periods on a green premium, which is most important. So among other factors, by offering this energy reduction and then energy offset as a package to these clients, solar energy becomes obviously more of an eye-opener. So I'll give you an example. Typically, we could apply solar photovoltaics to remove 50, sometimes even 100% of a utility bill with a payback period within 7 to 8 years or less, because of our engineering capabilities, not just the application of solar energy, it is the application and synergy of solar energy and engineering together that could provide that. And while solar panels are going to last up to 30 years plus, so obviously it makes sense, and it makes sense even now before any increase in the utility cost. So I mean, the thing is, this does so much more for organizations who take advantage, apart from the obvious green image that they get. Energy resilience is improved. And what it does is also pre-position us. It pre-positions all operators within the space, even residential owners, to tremendously boost resilience of the utility grid and our country entirely by extension. So, and this is going to, the game changer here is the feed-in tariff. And I mean, personally, I want to hear from our next panelist, Mr. Craig Boodoo, who Mr. Georges will introduce shortly. But I mean, you could imagine a solar system without a battery bank is going to significantly reduce the cost. Significantly reduce the cost. And everybody is going to be able to install solar energy and afford it, and increase that payback, increase the attractiveness of that payback period. So I'm going to stop there, Kamal, and back to you. Thank you very much again for the opportunity to be here, and I'm open to all the questions that our viewers have. Thank you very much.
All right, Graham, thank you very much for an informative presentation, putting our next speaker on the spot somewhat, but I am sure that he's well prepared to deal with that question and so many more that will come up this evening. So thank you again. So as Graham just said, our next panelist is Mr. Craig Boodoo. He's the Acting Senior Energy Analyst at the Renewable Energy Division at the Ministry of Energy and Energy Industries. Craig Boodoo is the acting he has over 2 decades of experience in the energy sector and has represented the ministry at various forums. He has worked in the areas of drilling, completions, workovers and production, resource and reserves management, health, safety and the environment, oil spill response and accident investigations, and also renewable energy. Currently, his portfolio includes utility scale renewable energy projects involving solar PV and wind turbines. An additional area of interest for him is the adoption of green hydrogen on a world-class scale. Mr. Boodoo has a BSc in chemical and process engineering with postgraduate qualifications in petroleum engineering. Mr. Boodoo, good evening and welcome.
Hi, good evening, everyone. Thank you for that introduction, Kamal. I'm looking forward to this discussion moving forward.
All right, so before you take Graham's question, I have one for you. Tell us about government's vision and strategy for renewable energy in this country And more importantly, what actionable steps are being taken to achieve this?
Okay, great. So the government is very committed to reducing this country's greenhouse gas emissions. And how we are going to do this is through the promotion of renewable energy and through energy efficiency. This commitment has been elaborated in government's National Development Strategy Vision 2030 under Theme 5, placing the environment at the center of social and economic development. Additionally, the government has had signed on to various international commitments. One such commitment is the Paris Agreement. The government would have signed on to that in 2018. And one of those commitments is to come up with nationally determined contributions, also called NDCs. NDC is simply a climate action plan to cut emissions and to adapt to climate impacts. Zooming back to Trinidad, our NDCs were developed under the United Nations Framework Convention on Climate Change. It's called the UNFCCC, and it's based on its carbon reduction strategy, and is consistent with the implementation of the provisions of the National Climate Change Policy. The aim of these NDCs for Trinidad and Tobago is to reduce the overall emissions from the three main polluting sectors, which is power generation, transportation, and industrial. And the aim is to reduce it by 15% by 2030. This is equivalent to 103 million tons of CO2 equivalent taken off the grid. The government has also committed, apart from these NDCs, to produce renewable energy power to be 30% of the demand from Trinidad and Tobago by 2030. And to this end, how do we action this? In December 2020, which is a month ago, we signed the first utility scale solar PV project. Construction is expected to start in Q2, so within a couple of months, we'll start construction of this plant with first electricity from this plant going to the grid in 2024, so within a year's time. The consortium that signed this agreement included Lightsource BP, Shell Trinidad and Tobago Limited, and BP Alternative Energy Trinidad and Tobago Limited. And these are very big players, not just in Trinidad, but worldwide. It just shows how attractive these projects can be. A little more on that project is that it's 112 megawatts total, and we're going to have the larger plant in Kuva in Greater Castle. That's going to be about 90 megawatts, and then we have a smaller plant in Trin City, and that's 20 megawatts, and that is going to be in association with the University of West Indies. This project will also be actually the largest of its type in English-speaking Caribbean, so it's a significant leap into the renewable energy spectrum. As Graham would have mentioned, the feed-in tariff. So the government has also started to implement or develop really a lot of policies that's to create an enabling environment for renewable energy to be implemented within the country. The feed-in tariff, right, was developed through a partnership with the United Nations Development Program. And one of the plan is to diversify our energy mix to include power generation from renewable energy sources, and to include a lot of small-scale independent power producers. So everyone who has a house, who has a roof, can basically get into the action, investing with people like Graham will come and design your system for you. And as he said, the payback should be within 5 to 8 years maybe, and these panels last 20 plus years. So if you pay back within 5 to 8 years, then you have 12 years plus to make a profit on the system. And these will also contribute to saving on our NDC targets. We are also working on a renewable energy policy. Again, this is to amend our current policies and legislation to make them more conducive to power generation by renewable energy and encourage energy efficiency. Another project we're working on, the wind resource strategy. So a recent study by the IDB, the Inter-American Development Bank, identified over 50 gigawatts of wind potential for Trinidad and Tobago. Just to be clear here, our current installed capacity is 2.1 gigawatts, and we identified about 50 gigawatts. That's 25 times our current installed capacity. So that's huge, right? So they did a very general project, and what we do with our project now is just zeroing in within Trinidad and Tobago to identify actual areas where the wind is the highest potential. Then we're going to go out there with measurement equipment. The equipment needs to be set up there for about a 1 year period. And after that, you take those measurements, you analyze it, you confirm the potential, and then you could go out there with an auction. A recent auction last year in the coast of New Jersey and New York in the US netted $4.2 billion. So it is a significant potential. And if we could realize at least even 12 gigawatts of that potential, we can go into the green hydrogen into a very worldwide scale. Basically, we could produce as much hydrogen as we are currently producing from natural gas right now. I think I might have gone a little bit ahead of my time, so I have more to discuss. So we can discuss as we go forward, Carol.
Yeah, that is absolutely not a problem. And I'm sure you being in the chair that you hold, there will be a lot more questions that are coming your way this evening that will allow you to flesh out some of the government's plans and some of the projects that you spoke about in some more detail. So thank you very much for sharing your knowledge with us. And obviously your perspective is especially important to achieving today's objectives. So at this juncture, we would like to open the floor to the audience who may have a question or two for the panelists. We actually hope a lot more than that. We're seeing some coming through already, and some of you have shared questions in advance that we'll also try to answer as many of them as possible. So I will start with one that came in just a short while ago, and I will direct it to Mr. Boodoo. And the question is this. One of the major challenges in utilizing renewable energy in small island developing states is the land use requirements for various renewable energy technology. Recently, the government suggested that the country should move towards renewable energy sources towards attaining carbon neutrality. In the recent discussion, harnessing offshore wind resources was put forward as a potential alternative, right? What is the potential for this technology within our geographic location, and how financially viable is such technology in TNT and the region given the current economic climate?
Right. So as I mentioned, I'm not sure who posed the question, Mr. Mohan. Yes. So we have identified what the IDB, the Inter-American Development Bank, has identified over about 50 gigawatts of energy from wind resources offshore. So we have a huge potential. As you said, we are a small island, so there's not a lot of space on land to do major solar, major wind. So our most promising scenario is to go offshore. So yes, it's very promising. As we said, we already have BP, we have the Shells here who are invested billions or trillions even in renewable energy in the Middle East and in the North Sea in the US. So we have the players here already. They are interested. I believe that most of the projects will need some government financing or support, but the private sector is going to invest a huge amount of money into these things. We have a lot of aid coming in from the various aid agencies as well. I'm not sure if that answers the question.
If he has maybe a follow-up question, Akash, feel free to put it in the chat as well. If I may just piggyback a little bit on it, you mentioned there's significant interest, but I'm sure a number of people would be interested in how quickly we can move from interest to actualization.
Right. So as I mentioned, we signed our first utility scale solar project, PV project in 2022. The RFP for that went out in 2018, 2019. So it took about 3 years from time we sent out an expression of interest to actually signing the dotted line and construction start within a month or two. So it took about 3 years. It was a very steep learning curve for us. And the hope is that with all these learnings, and our minister has gone on record as saying he will go to another RFP for utility scale solar, wind, or whatever RE someone can show is viable within a very short space of time after the first one is signed. So I would anticipate that within a year and a half or 2 years, we should be able to sign these agreements, or maybe less time even.
Right. Thank you very much. The next question I will pose to Dr. Harak Singh. It is, are there any recent examples in Trinidad and Tobago of innovative engineering solutions that have advanced the transition to a more sustainable energy future?
There have been, but they are not on a large scale at the moment. There have been some initiatives, but one of the major things we need to do before we can move forward is to do some training in this area. And this is one of the things that will lead to projects. So some of the projects, for a long time now, Kamal, there have been solar projects many, many years ago, but they are small scale projects. The larger ones are only now coming on board. And we really have to sit and wait and do our little part in trying to push forward to get some of these projects actually done.
Okay, thank you very much, Dr. Harak Singh. We have a few questions.
I'm sorry.
We can talk some more. No, go ahead.
Yeah, we can talk about small scale projects like 2 kilowatt systems and so on. But we have that at the UWI, we have one at UTT, there's one at Mount Hope, just photovoltaic systems. But those are relatively small scale. There are some larger ones and some were done by different companies. One of the companies that has been in existence for a long, long time, DC Power Systems Limited, and they have done some larger installations. So there are some projects at the airport, the solar LED lights and so on. But I think we are looking now for more major projects, which seem to be oncoming.
Okay. As you mentioned that the whole issue of affordability comes into play. And so the next question will be for Graham. How can we make sustainable energy affordable? Pretty straightforward and simple, but I'm sure it's a very loaded question as well.
Yeah, I think several elements to consider. But as far as I would have mentioned earlier, you know, the importance of the feed-in tariff and how that could change the way solar energy is consumed in Trinidad and Tobago. And we could learn from our neighbors from this as well. Barbados has something called the Renewable Energy Rider Program, which is something similar to an FIT. But the cost of solar ideally has reduced over the last 10 years significantly. So the cost is coming down and the technology is becoming more commercialized. So I have no doubt that in the future that it would continue to present itself as an option for residential, for the broad range of industries. I think that there are other technologies, because as we talk about solar energy, yes, it's important. There are a lot of other renewable energy schemes, but solar panels are only 22% efficient. But the good news is that there are a lot of other technologies like tandem solar cells, something even called triboelectric nano generators. There are things like gallium arsenide and different applications of solar energy as well, like central solar power, CSP, if I'm not mistaken, which uses molten salts for storage. And I see we have a question about storage there. So maybe I could address that instantly. That is one of the methods of storage. There are other hybrid systems of storage. There's pumped hydroelectric storage, using excess solar power from the grid that's fed into the grid or supposed to be fed into the grid to pump water up a hill and then store that to be powering some hydroelectric turbines in the future. But as far as solar energy in our application for residential and commercial and industrial clients, we use lithium-ion gel battery storage. And that obviously provides power in the event of a night period or a power outage. It depends on the configuration, the electrical configuration that the client wants. So I think I'll close there. That answers the question.
All right, Graham, thank you. We have a question that follows up on a statement that was made earlier by Mr. Boodoo, but I want to pose it to both Graham and Mr. Boodoo, and you can share the responses. So will that utility scale solar plant that was mentioned actually result in lower gas consumption at the power plants? I ask because on a grid the size of Trinidad, spinning reserve, that's backup, is needed to account for fluctuations in solar output. This means that gas turbines still need to spin to smooth out solar output. I'm curious whether or not the studies were done to quantify the natural gas savings in the electricity sector.
Right, so I could go first. So yeah, studies were done before the utility scale solar project was signed. Those studies were done and would have involved TNTech, Ministry of Public Utilities, and other external parties. There is going to be a gas savings and a cost benefit, I guess you would call it. Definitely. Graham, I'm not sure if you want to jump in.
It's a difficult question, Sienna, but I would say that, I mean, studies were done, as Craig said. So, I mean, hopefully that we could reduce our natural gas consumption. I mean, distributed energy resources like this solar energy farm and others like combined heat and power are very important to ensuring grid resilience. So I think that eventually, as we see more interconnection of renewable energy resources into the grid, that we could obviously see a significant turnaround in the amount of natural gas that we use currently to supply from power gen and all these other power generation companies. So that's just my 2 cents on it.
Graham, as you have the floor, there was a question that was posed directly to you, and it is, what type of batteries, and this person is asking specifically for the brands that are best utilized in solar systems and the best program used to design a system?
The best program used to design a system?
Yeah.
So we design our systems ourselves, calculations. There are several other programs that you could use to like double check yourself. And could probably prove to be very helpful. I will ask that you do your research on what is existing out there. There are some free softwares. There are softwares that are offered by companies that actually supply the equipment. But in terms of the brands of energy storage batteries that we use, I probably could say that there are Trojan brands. There's brands like Victron and several others with a warranty of like, well, lithium-ion batteries probably last about 10 years or so. But reverting to the point I had before, you know, removing battery systems could obviously prove to be very beneficial to customers, no matter your industry, because obviously you're removing the bulk cost of any solar energy system, be it the batteries, right? So it's gonna open up the market, ideally. I hope that covers all the questions that were asked.
Graham, thank you. So before today's webinar, we invited people to submit questions in advance. So we don't want to ignore them and not address some of their questions. So I will go to some of those. And this one will be posed to Dr. Harak Singh. And it is, and you mentioned this, you mentioned wind as a source of renewable energy earlier. And this question is specifically related to that. What size wind turbine is ideal to power an average home, and what considerations would be required?
Right, that is a very open question. One of the first things you have to do in a case like that is do an audit of your needs. So it depends on what your needs are, and it depends on whether it's going to be large scale, small scale, domestic, residential, or commercial. So one cannot actually give a figure offhand. So it depends on what the application is. So the first thing that needs to be done is an energy audit of the needs. Check what load you have in the house or the building or wherever. So you must get that audit done first. And then you have to design your system to accommodate that. So we need also to bear in mind that there is a particular efficiency of a wind turbine inherent in the turbine, and we have to bear that in mind before we can actually say I need a 2 megawatt or 2 kilowatt or whatever. So it depends. It's a situational thing.
All right, thank you very much, Dr. Harak Singh. This
you
one
could talk about the household system, and for a house you will probably need about well, for a room or 2 kilowatts or so. So it depends. You have to build on that and expand. Whether you are going to go to a 5 kilowatt system or a megawatt system, it all depends on what you're applying it to.
And I knew when we were speaking earlier as well, for example, the location of your home and its proximity to good sources of wind are also factors that will play.
Exactly.
So this question is a little more topical and maybe a little controversial too. And it has to do with what is going on with the RIC. Graham mentioned it. So the question is, the electricity rate is expected to increase in the near future, but how soon can solar energy be available and affordable to the public as a viable alternative? And I think the controversial part here is the potential rate increase being proposed by the RIC. And that question is to Mr. Boodoo.
Thanks for that, Kamal. So the rate increase has been proposed by the RIC. It has supposedly been long in coming. The last rate increase of TNTEC has been a while now. They're currently doing consultations throughout the country, and I think every citizen should go out and have their say. It's impossible to say whether the rate increase would be increased at this point in time, and or by how much. I don't think anyone has the answer for us yet, because it should be based on consultations going forward. Sorry, what was the second part of the question?
It was how soon can solar energy, and I know there are options, for example, RESCOT, but I think this person is speaking on a more broader scale. Can solar energy be available and affordable to the public as a viable alternative?
Right, and it's been a few years now. You can walk into a price mart, you can walk into any of the larger stores and you can buy a solar panel, or you can order it from online, or you can go to Graham and folks like him, and they will design a system for you that you can use off-grid. Currently, it's not allowed to use your solar system and connect it to the grid. That will only be done if you're using a feed-in tariff system. So you can be connected to the grid, but the system that's connected to the solar needs to be off-grid. It's not going to be connected to the grid. Graham, you can talk more about that.
Yeah, sure. I would say that solar energy is affordable now for commercial and industrial clients. It makes sense now. For a residential customer, we more see the application of solar as backup power, and also a large percent of that is continuous power, merely because the interest is there and they want to prepare themselves for increasing utility rates. They want to become more resilient and sustainable themselves, so they do it. And we install solar energy systems for residential clients every single day. So it's happening, you know. I would also mention, okay, I wouldn't mention that, but it's too controversial, but I will close there, Kamal.
A little controversy is always welcome. It's so great. As you have the floor, this, I believe, is a follow-up from a statement you made earlier. How is the spinning reserve catered for in renewable energy? And would that mean energy storage or capacitor banks being used?
I would say yes, but we don't particularly have peak loads, if I'm not mistaken, in Trinidad and Tobago like they do in the US, significantly peak loads that require the interconnection and supply of spinning reserve from distributed energy resources. And IEEE 1547 talks about interconnection, and there are other standards that talk about it as well, but I'm unable to give a concrete answer to that question. So that I'll leave it as that.
We want to return now to our chat in terms of questions from today, and this one is for Mr. Boodoo. I understand the need for utility scale renewable energy plans to reduce the energy generated from fossil fuels. However, what about at the level of private residences and off-grid generation? Countries like Barbados allow for such things, but the political situation in Trinidad is not necessarily supportive of this. Do we intend to get citizens involved, or are we just relying on the major producers or companies to drive the sustainability?
Right, so we actually have a number of demonstration projects right now in association with various entities, including the UNDP and the GCCA+. We've installed solar power in several schools and several community centers. These are centers that will be used as emergency shelters. So in case there's a hurricane or something like that, and you need to take shelter in these areas and electricity from the grid is off, you will have electricity still. You'll have something to run a fan, run the cool storage system so that life can continue. The GCCA Plus has installed a system at Nature Seekers in Matura. Their system is totally off-grid. So it's I can't remember how much, it's 6 or 7 kilowatts of solar panels with associated storage. So before they used to use diesel back there, there's no electricity at all. And now they have that to use, right? With respect to residences, really, that is going to be favorable, as Graham mentioned, only, I think, when the feed-in tariff becomes a defect. We have developed a feed-in tariff, and we are waiting final review before it goes to cabinet, and hopefully will be implemented soon.
All right. Thank you very much. Right now, increasing capacity and also getting our young people involved in renewable energy is extremely important. We need to get their minds around the whole renewable energy conversation now so that they'll be making some better decisions a few years on. So we have 2 questions surrounding capacity and also young people. So the first, and these will both go to Dr. Harak Singh. Are there training programs or initiatives to bring skilled or professional people on board potential or ongoing projects with respect to renewable energy? You'll take that one first, and then I'll ask the other question about what can be done in secondary school. So let's tackle this one first.
Okay. Yes, so some time ago, we realized that whenever we have a need in this area, we always bring people from abroad. So we decided to start some concrete programs. We've always had some programs in solar energy at the solar energy training at the undergrad level at the University of the West Indies. But in 2013, we developed just before that, the MSc in Renewable Energy Technology, and it covers all the technologies, and we look at all everything that goes with it, the integration, the energy use and auditing, and looking at efficiency. So it's a holistic program. So this is what we have at the University of the West Indies. We also have some at UTT, I believe. I don't know all the details about that. But apart from that, we started many years ago when we started talking solar energy. We did training for the personnel from the Ministry of Energy and Energy Industries. We carried out a very big program for teachers, because one way to reach the young people is through the teachers. You can manage the teachers, but not the thousands of students. So we did a renewable energy training program for teachers. We had about 80 teachers from various secondary schools here in Trinidad. And it was I think it was a 2-week training program, was very, very successful. And we also went to Tobago and did the training there. So the hope was that the teachers will pass this on to students, but it may or may not have been done. And there's supposed to be a second phase of this training, which is yet to come on. I think all the funding and things is there for that. And I hope that the ministry will deal with that in the near future. But one way to deal with the young people is by actually getting into projects with these students. And I can go that when you ask the question.
I'm glad you said that, because the specific question is, what are some sustainable energy projects that can be done in secondary schools aimed at preparing children for the future? So yeah, some practical examples I think would be helpful for that question.
Yeah, so I think before we actually do some of these projects, students need to be trained to be able to walk through a room, for instance, see what appliances there are, what the needs are. I think get used to looking at these at the little plate in the back to see what the load is in that particular device. And you would look at simple things, a blender, an iron, various things. So they need to get use of that. So some training in that area is important. So students must study how much electricity they need for a particular project. So there are design and build projects and very, very simple projects that we could start depending on what age the students are. A solar distillation unit is a very simple thing to build. Of course, they will need a little bit of resources, some materials and so on, but it's a very thing. So you do training in simple solar energy devices, and we can have the students participate by building. We can have them work in groups. Something like a solar box cooker. You can take 2 cardboard boxes, fit one inside the other, put your insulation and retrofit it and make that into a solar box cooker. And then you can do more sophisticated types, you know, like the concentrated types. Another thing that you can just take like one of those plastic gallon things, oil bottles, clean it out, use that as a storage, and you can make a simple solar water heater. And these are things that students can do. They all have cafeterias in the schools. They can also start looking, collecting and composting, looking at waste energy, and waste decomposes. As waste decomposes, it creates heat. So they need to learn these things by just doing it, and teachers can guide. There's also to design and build and test a simple wind turbine or a pinwheel and see how it works. Another simple project is changing the light bulbs in the school and checking the electricity consumption, what they had before and when they changed to these. And Kamala, if I may just at this point mention, we are talking a lot about what we can do, and we are all assuming that it's only electricity generation. It's a major thing, but we have all bypassed a very simple thing which we can do. The photovoltaic systems might be expensive, but why not start with a solar water heater? If everybody is using electric water heaters and we continue to pay for the devices and we continue to pay electricity bills for heating water, solar water heater may start a little bit high, but once you have it installed, it goes long periods and you are not paying. I have one since 1994 and I have not had any major expense with electricity bill for heating water. So.
No, that's an extremely good point. I have.
Yeah, I think that's something we can do.
I have family up the islands, and there's a greater push towards using, I think, solar energy up the Caribbean because of the high cost of electricity. And they've shared very similar experiences to you in terms of things like water heating, using panels to power the appliances that consume the most electricity and so on. So that's a very good point. Thank you for that. The next question will go to Graham. I'm considering establishing a solar power desalination system for a facility. Is this advisable with respect to the reliability of supply?
Yes. The short answer is yes, and we've done it before on a government project. Actually, we've powered desalination plants as part of a wider range of loads. AC units, lights, fans, electronics, kitchen equipment, kitchen appliances, etc., and security systems. So desalination plants, we have a particular design for that if you were to power that exactly. But obviously in the design and engineering of a system, we're not going to design something that's specific for, we can design something that's specific for that desalination plant. But obviously we want to give you client most value in terms of dollars per watt, if you were to take it like that, for your investment. So if it's a desalination plant that is requiring continuous power, then that's probably a different story. Still can be done, but reach out and let's have a discussion.
Yeah, I was about to say that may be something that requires some more information to give a comprehensive response. So feel free to reach out to Graham. The next question is to Mr. Boodoo. Does the government have any plans on the horizon to upgrade our current grid system to a smart grid system?
That's a good question. So that would have to be done by TNTech. And to be honest, I'm not in that loop. So TNTech reports the Ministry of Public Utilities. The Ministry of Energy is responsible for power generation, but not for the distribution, which is public utilities. I know that they have spoken about doing studies, but I'm not sure how advanced they are. I'm not sure if any of the other panelists would have any ideas on this.
Well, presume that, you know, as we see the onset of all these distributed energy resources, DERs, coming into the grid, and we see that bi-directional flow of power, see the feed-in tariff, maybe a trade-in scheme, something like that taking place, and more renewable energy technologies in general. I presume that, you know, it will work in tandem. All the policies will work in tandem with grid hardening and smart grid upgrades to ensure that, one, we have the capacity, and two, the capability and technology to manage all those inputs.
Mm-hmm. Okay. Craig, you will also take the next one because this has to do with availability of jobs in the industry. What about the availability of jobs in this field? This person says, I've completed a BSc in environmental science and sustainable technology, and it's difficult to get jobs, to get a job in such a field. A lot of graduates from my year are employed, but it always seemed to be in other fields. So I guess speak to the present and maybe talk about what is on the horizon in terms of jobs in this particular field.
Right. So at present, we are at the stage where a lot of jobs in renewable energy is going to be maybe installing small scale, maybe designing, maybe working with folks like Graham, maybe being at the universities and actually teaching these things at schools and the like. So the future, especially if we go into large scale utility projects, if we go into green hydrogen, then the limits are boundless. I think there's going to be a whole new industry. It could be on the scale of Point Lisa's, what happened in the 1970s, 1980s. I think we could have a whole new industry basically, and professions that are dedicated to wind energy, dedicated to green hydrogen, dedicated to maybe desalination plant if you need additional water to produce this green hydrogen, and then transporting this hydrogen to the plants at Point Lisa's to use. I'm not sure if Dr. Harak Singh or Graham will have any insights on that as well.
Yeah, please.
I think, well, Dr. Harak Singh, the learned Dr. Harak Singh, I presume that you might have some input on this as well, but increasing technical capacity is of utmost importance as we prepare for an energy transition to prevent structural unemployment in a country that is oil and gas based, and our knowledge and capabilities is within petrochemical and oil and gas. So, I mean, obviously those industries will remain to an extent, but there are a lot of training opportunities through the University of the West Indies. We employ people who have actually done that master's in renewable energy technology. We employ people that have done our own training courses. We've employed people that have done training courses with SBCS even. There are a lot of others, and a lot of good ones, in fact. But I think that it's important to educate yourself, where in the age where you could just Google something and pay a small fee to just learn something, or no fee at all. YouTube, anything on Google, as a matter of fact, you could research something and learn a lot about it yourself for free. But if you really want to dive deep into the technology and get involved in the business, that's a good place to start. And there are local chapters, like I would have mentioned before, the Trinidad and Tobago Association of Energy Engineers and APETT even, that can provide training, can provide like these partnerships with NIHERST. So I would say reach out to those organizations to better prepare yourself. But that's what we look for in terms of like jobs. How active, how proactive are you in terms of learning about it yourself? It's not rocket science. Solar energy is simple. Honestly, it is. It's if you have a background in electrical engineering, not even electrical engineering, but as an electrical technician, it's a fairly seamless transition. So yeah, I would say that's my take on it. But Dr. Harak Singh, what do you say?
Yeah, when we train the students in the MSc program, for instance, many of them just don't have choices. They have to go back to their old jobs, and they're always very sad about that. I know that one of my students is working with you, and I'm very happy about that. Many of the companies that we have in renewable energy at the moment in Trinidad and Tobago, they are small companies and they can only employ some students. My hope is for this industry to open up a little bit more, so more of the students can be able to join these companies. I know there's another company that works on energy efficiency, and almost every year he asks me for a recommendation for a student who can work with him. And I have done that quite a few students I have put to him. And he's been very, very pleased with their performance up to now. There is a new one that's getting on stream with that company. But when I teach in this program, I tell them, we are training not only for Trinidad and Tobago. We are the University of the West Indies. We are training for the Caribbean region and beyond. There are jobs out there in some of the other islands. And I know some of my students have gone to Barbados and found jobs. We are not saying that we want to send our people out there, but there are some openings and they have to reach out to these. They have to reach out for these in the initial stages when we do not have all the possibility here. But with our government incentives, and Craig spoke about this and so on, I'm hoping that in the near future, we can see this expansion of renewable energy development in Trinidad and Tobago, and that we can actually have an intake of our own students working in these companies. It's my hope.
I would say also, Dr. Harak Singh, very, very foundation you put there, a view on it, very good view on it. But we have had instances where our consulting company here, employees from Trinidad have come to the US and actually consulted on energy improvement projects for large-scale utilities and several other heavy industries in Georgia and other states within mostly on the eastern coast. But opportunities exist, and if you possess the correct skills, technical know-how and capability, you have the training, you have the experience to back it up. I mean, experience is important, of course, and you could get that through a number of means, as with training. So the opportunities exist on an international scale. And as Dr. Harak Singh said, it's the University of the West Indies, not, I mean, there's the UTT as well, but University of West Indies has a very broad reach. So, yes.
So, Graham, and to add to what you have just said, some students are very enterprising. Some have worked with big companies like National Petroleum and so on, and some of the smaller companies as well. But in addition to that, I was very, very pleased to learn that quite a few of my students have set up their own renewable energy companies, mostly solar, mind you, but they have set up the companies. They are small and they are working and they are building and they are doing good work. So nice. That's also one option, that you can start something of your own or get a few people together, pool the resources and build on some kind of business.
Of course.
Some of the incentives that were mentioned, Dr. Harak Singh, there may be opportunity now, and now might be the time to start investing in something that is yours.
Yes.
Earlier, someone mentioned the energy transition, and there is a question that asked specifically about this, which is, how do you see us navigating the transition from a strict oil and gas-based economy to a renewable energy one? And that question is posed, I'll put to both Dr. Harak Singh and Mr. Boodoo. Ladies first, so Dr. Harak Singh.
How do we transition? It's, we are talking all the time, and how do we make that transition? And very often that depends, and I know that's why you asked Mr. Boodoo, it depends on legislation, on policy development in this area, and what offerings we can get from the government in this area. The transition is not difficult, it is not easy, sorry. And even the Prime Minister has said that, and I will talk about that maybe in a little while in closing, but the transition is not easy. but the will is there. So if we have the political will, so I say a lot of this really depends on the drive from the government. And also very important is collaboration with industry and the private sector. That's the only way we could really make significant change. The government cannot do it all alone. We also need international organizations to work with. And this is looking at the overall picture. There are many other things we can do at an individual level or at a school level to make that transition. And one of the most important things is education. People are not going to move unless they know about it, until they feel comfortable, until they feel safe with it. So they need that training. We need sensitization programs. And through Ministry of Education, the training program we had done for the teachers was through Ministry of Energy and Education. So we need to have this kind of linkage between the different players, and we can work with these students together to build their confidence in these systems. So building confidence is one of the major things in moving forward.
Mr. Boodoo, if you want me to repeat the question, or are you
No,
good?
it's fine. It's fine. It's fine. So the energy transition is happening. It's happening. Trinidad is a very small fish in a big ocean, right? The energy transition is happening. We're being pulled along by the world. I don't think we have a choice in the matter. Having said that, we are at oil and gas province. Natural gas has been touted as the transition fuel. So next medium term, up to 10, 15 years, natural gas is going to play a very important role. So basically, all natural gas you can produce is going to be used up. That's not a question, right? What is important for us to capitalize on our human resources? So we have a very well-trained population. Both the University of West Indies, we have the University of Trinidad and Tobago, and there's a lot of other institutions. We have a very well-trained population. We have a lot of infrastructure that exists. We have the petrochemical plants in NIHERST, which is what built everything in Trinidad and Tobago, I believe, in the last 20, 30, 40 years. And these things will not just go away. That's where our advantage is. So if we could capitalize on renewable energy, if we could capture some of this wind energy, and we could use it to make green hydrogen, if we could use CCUS, which is carbon capture and usage and storage and sequestration, as Dr. Harak Singh mentioned. If we take that technology, we capture the CO2 from the plants, we inject it into deep reservoirs, either saline reservoirs or mature oil reservoirs and gas reservoirs, then we create blue hydrogen. And the same blue hydrogen and green hydrogen can be used in the plants. Right now we use gray hydrogen, gray as in men in gray, that type of hydrogen which is produced from natural gas. And that emits a lot of CO2, right? And that's the problem with it. If we can capture that CO2, as I said, and make blue hydrogen, or if we can make green hydrogen, which is using, it's a private school experiment. They take electric charge and pass it through 2 electrodes in water, and you'll see hydrogen bubbling up. If you put a soapy solution there, it actually bubbles up. We do this experiment in secondary school, and you can light it with a squeaky pop. You say that's hydrogen, And I think that's the way we're going. We're trying to capitalize on our existing infrastructure, our existing human resource, and move forward with the transition. So you're going to go big into wind if we could, or maybe even solar, or we may need to import our renewable energy from places in the mainland even, or from Dominican Republic and those places, not Dominican Republic, Dominican, those places are going up the chain where geothermal might be possible. I saw someone sell about a waste heat.
Yes.
You may be aware of the New Gen project, which is supposed to use electrolysis to form green hydrogen, well, low carbon hydrogen and low carbon ammonia for sale. And that project is going to use the waste heat from some of the plants at NIHERST. So we are moving forward, but at the same time, we are an oil and gas province, and we will capitalize on both at the same time to maximize our natural resources for the benefit of people. So, yeah.
Mr. Boodoo, this one sort of ties nicely into some of what you were saying. So apart from solar and wind energy and others, are there actions being taken by government to prepare for the future of electric vehicles?
Yes, so the Ministry of Planning and the Ministry of Energy have come up with EV, electric vehicle mobility policy. And we have, well, as everyone would know, we also have incentives for EVs. We have budgeted some money as well to create electric charging highways. So basically, we would have chargers along Trinidad and Tobago where you can pull up and charge your electric vehicle.
All right, thank you very much, Mr. Boodoo. So the next question goes to Dr. Harak Singh, and this is something that we've been speaking about quite a lot. It's remote work, alternative work arrangements, and so on. And to what extent do these things, remote work, alternative work arrangements, carpooling, can reduce our carbon footprint? In other words, are they significant enough to have an impact?
Yeah, actually, this is all part of sensitization that we need to be doing. And it's all coming under the umbrella of energy efficiency. It can be loosely put into that thing. So there's no question about it. Carpooling makes a lot of sense. If we go with one car instead of 3 cars, we can definitely reduce our carbon output. So yes, remote, I wasn't sure what you were saying when you were saying remote. You mean
work from
like
home?
Online?
Yeah, work from home. So companies adopting, I guess, alternative work arrangements. Some work from home,
Yes.
some alternate your days.
Yes, and that actually, of course, there are less people on the road, hopefully, if we have the work from home scenario. It has advantages, but it comes with disadvantages because people may not output as much as they would. And it depends on what kind of job. There are some jobs that need you to be on spot. So you really need to be there. But yes, it's no mean thing to just work towards remote and work towards carpooling and so on. Those things definitely help. One of the major problems we have in Trinidad and Tobago, because our electricity and so is so cheap, is a lot of waste and a lot of inefficiency in our operations. And energy efficiency is something that we need to learn about it if we don't know, to change our mindset and to change our habits in operations. You know, simple things like turning off the lights, turning off air conditioning and so on. Those are all leading towards energy efficiency. They're all energy efficiency measures.
All right, I know Mr. Boodoo addressed the question in some way of is any work being done on waste heat and thermal recovery systems. I'm not sure if you addressed the specific issue of thermal recovery systems. So the example given, vehicles, server rooms, air conditioning, and so on. Before we start to bring our session to a close, I don't know if you could address this a little more directly.
So
I could yeah, if you want,
go ahead, Graham, yeah.
And you could add your 2 cents after. I would say in Georgia right now, we are consulting with commercial and industrial companies to improve their HVAC using things like economizers, things like building management, airside economizers, things like demand control ventilation, things like energy recovery from exhaust. Things like that could be used as a means to improve the energy efficiency of HVAC systems, which in most cases is a very high consuming item in the list of loads that you uncover for these organizations, right? So it's one of the main things that we consider in an energy audit, amongst others, depending on the application and the industry within which those clients operate, right? So by all means, yeah, it's a very important thing. Waste heat recovery, you see it applied in plants through economizers as well. Who was it, Mr. Boodoo? You heard Mr. Boodoo talk about heat recovery as well as it relates to hydrogen and ammonia production in Trinidad and Tobago. So I would say it's being considered. It's something that's not on the back burner, it's something that's actively being considered now in Trinidad, internationally, as it relates to those systems.
Yeah, so I agree with Graham, and definitely an industrial scale. I don't know it's being considered in Trinidad on a residential or on a smaller scale, but definitely on an industrial scale, it makes a lot of sense and it's being done.
Of course.
All right, so we have one, I think, final question before we start to take some closing comments from our panelists. It's amazing that an hour and a half has passed already. So the final question is, do you think that renewable energy will be the dominant energy source in the energy market in the future, or will it be a hybrid energy market of both renewable energy and fossil fuels? And I think this question is a bit open. So each one of our panelists can tackle if they so choose.
I would say both, by all means. So it's obvious, as Mr. Boodoo would have mentioned, you hear fossil fuels aren't going to be around forever. It's obvious, right? It's a finite resource. Renewable energy is infinite, right? Infinite. But that is, for now, at least you would appreciate that the value and the energy density of something like natural gas can give you compared to a solar panel is obviously much higher. So you could appreciate that it does add a lot of value, and there are ways that we could use it to reduce, there are technologies that we could apply to reduce the emissions from it. You hear Mr. Boodoo and Dr. Harak Singh talk about CCS, carbon capture and sequestration. Yes, CCS. So those things are methods, and we actually have methods that we are applying now to industrial clients to make their entire facility net zero within a matter of years. It's novel technology. It is some in parts carbon capture and sequestration, but there are a lot of factors to consider. But in my take, and I'm sure the panelists might have their own as well, for now, there's going to be a very a good balance between those two types of energy resources.
Yeah.
So I'll leave it open to the panelists if they have anything to add.
Right, so definitely in the short term and medium term, fossil fuels will not be going anywhere, so it's going to be a hybrid. Depending on your source, I think a lot of publications would quote that solar, while electricity generated from solar is now the cheapest form of electricity in the world. So that's something that is worth mentioning. What is worth mentioning as well is there are a lot of, as one of my friends like to say, geopolitics going on as well. So for example, the war in Ukraine, all European countries, all first world countries were touting, we're going renewable. As soon as there's a war, or as soon as there was a COVID pandemic and things became short, everyone went back to coal. Coal is one of the cheapest forms of fossil fuels as well. And it's not clean, it's very polluting, but sometimes you have no choice, right? And I believe though, as like technology advances, we are talking about nuclear, modular nuclear, small modules. We're talking about nuclear fusion, not just nuclear fission. I think there could be a step change in technology that could maybe make fossil fuels a thing of the past. And that is why it's very important for us to get the fossil fuel out of the ground now, use it and reinvest into renewable energy and reinvest into the people so that we can continue to live fairly comfortable lives. Some people say they haven't had in Trinidad, but we actually have fairly comfortable lives in Trinidad. For some people who've traveled the world, I mean, some other people you see haven't really had it. Our neighbors, sometimes they have a lot of resources, but it remains in the ground and isn't being used for the benefit of the people. So that is one goal, to make sure that our resources are available and can be used for the benefit of the country going forward. Hand over to Dr. Harak Singh.
Okay, thank you very much. So my simple answer to this is, are we talking Trinidad and Tobago? Ms. Felix was asking a question, or is it worldwide? If it's Trinidad and Tobago, it has to be hybrid for quite a while. There are other parts of the world which may be moving towards 100%, but it will still be hybrid. We can look at our neighbor in Barbados, for instance, and one or two other islands. They are moving towards 100% clean energy electricity generation, and they will probably achieve it. Their needs are not as high as here in Trinidad because we are so industrialized, and it's possible. It's quite possible in them. But yes, I would say in Trinidad, more fossil fuel for a while before renewables can get close to taking over. But Mr. Georges, if we are trying to close here, do I have your permission to, I want to leave on a positive note. I want to leave some hope for our panelists. And I really would like an opportunity to quote from our Honorable Prime Minister, just to be able to give us some hope, all of us included.
So we were at the point of going to invite some closing remarks. So I think this is a perfect time for you to do so. And when you are done, I will invite Mr. Jones and Mr. Boodoo to give theirs as well. So the floor is yours, Dr. Harak Singh.
Okay. So Mr. Boodoo spoke about some of the initiatives and policy from the government and so. But just so people will know, if you don't know, on November 29th, 2022, the government launched the Roadmap for Green Economy in Trinidad and Tobago, and that was developed by the IDB in collaboration with Ministry of Energy and Energy Industries National Energy, and they actually came up with the best option for Trinidad and Tobago, which was offshore wind. And there are reasons for that. There's large potential, but for me, my recommendation will still be solar and wind, even on land. The thing about offshore is that the potential is very, very high, but working in a marine environment is very difficult and can be very expensive. So that's one of the things that I want. Right. The second point that I want to make, the Prime Minister again, a review of the country's power requirements has projected peak demand to increase from 1,400 megawatts in 2022 to 1,600 megawatts in 2032. During this period, the PPAs of two of the country's major independent power producers, representing 40% of the country's installed generation capacity, are due to expire. So he is saying we therefore have an opportunity to achieve much of our target of 30% of power from renewables. It's kind of riding on a sad thing, but okay, he is looking at that. But he is still saying that, however, the transition to renewables is not without challenges. And we all very much are aware of that. And I wouldn't take too long, but I think this is pertinent in this discussion to close off. So he's saying it is a government stated objective to increase power from renewables to meet the 30% of the country's requirements. And he's talked about the large projects and so, which we are going to see in the near future. But we have to be practical, and we know that, say, the solar project, the solar parks project, for instance, it will come to pass, and it will come to pass by a series of stakeholders. And it is extremely important. You know who those stakeholders are: BP, BP Lighthouse, Shell, etc. And we cannot do it without them. We cannot do it without them. So what I'm stressing here is that cooperation is extremely important. It is mutually beneficial and respectful relationship. And we need to deepen this relationship and draw on the stakeholders' challenges and investments as we navigate this complex and vital energy transition. And lastly, Mr. Georges, while the outlook for development, this is coming from the Prime Minister, while the outlook for development of renewable energy is promising and attainable, we recognize that renewables cannot, in the near to medium term, replace oil and gas. And I think that's what we have been saying, but not that we are not going towards renewables. Long-term strategies that promote renewable energy and energy efficiency are necessary to attain that carbon neutrality that we are talking about. And low carbon technologies must be competitive in order to facilitate this transition. And I would say, yes, we have good hope for renewables, and I would like to see people moving in that direction, and we are there to help. Thank you very much.
Thank you very much, Dr. Harak Singh, for summarizing some of the salient points from the Prime Minister's speech at the energy conference that started on Monday, and putting some sobering thought to some of the discussion that we've been having today. At this point, I'd also like to welcome Graham and Mr. Boodoo to give their closing remarks.
Sure. Well, I guess, Dr. Harak Singh, you really said it all there. But I wanna make mention of something, a very new technology that I'm pretty sure most of our viewers here are aware of. Nuclear fusion has been achieved in the US. We're in some really exciting times there, especially when it comes to clean energy. So I would invite you to do your research on that, do your research on other technologies that are going to come and replace renewables. Well, solar energy as it exists now, more advanced solar panels, more advanced wind turbines, different designs. There's probably over 10 designs. I'm pretty sure Dr. Harak Singh, you're obviously aware of that as well, but some more commercialized than others. But awareness and education, educate, become aware of what is existing, train yourself, prepare for the energy transition that we are in the midst of, educate yourself as much as you can on it, do little short courses here and there, do a master's in renewable energy technology at UWE, But I would say seek mentorship programs, reach out to RESCOT, reach out to the local chapter of the Association of Energy Engineers, TTAE, reach out to APETT, reach out to NIHERST. All these opportunities exist whereby you could get the hands-on experience to back up your technical capabilities. And in conclusion, I just want to thank everybody for coming here today. Thank you for hearing my points, Dr. Harak Singh, and the floor is yours, Mr. Boodoo.
Take it away.
Hey guys, thank you for that. So I think you all said most of it. So just to reiterate, the energy transition is already happening. It's going forward. We are being pulled forward by the world. I would think we have a choice now. However, our strengths, we need to play to our strengths going forward, which is still, our petrochemical industries. The government is committed. Minister Young is committed. Minister Penelope Beckles, Robertson from the Ministry of Planning and Development. And that's very important. To enact change, you need the political will. Our prime ministers on board. So once they are committed and they're willing to support the policies going forward for renewable energy and for the energy transition, I think that would be successful. And last year, I just want to thank Kamal for moderating a great session. I'd like to thank NIHERST and APETT for inviting us for setting up this webinar and for all of the good conversation we had and all the questions that came into the chat. And over to you, Kamal.
Thank you. It certainly has been quite a good conversation, Mr. Boodoo. Thank you, to Mr. Jones, and to Dr. Harak Singh. I think we've had healthy and some impactful discourse throughout the course of this hour and a half, just a little over. So again, thank you very much. We had a good turnout this evening. Thank you to everyone who joined and also participated and shared their questions. Before we leave, just wanted to make a few announcements. The Association of Professional Engineers wishes to inform, if you're interested in being a part of their fraternity, you can email the association, and the email address is office@apet.org, and you can get more information about the process if you would like to join. Also, those of you wanting to learn more about the National Institute of Higher Education, Research and Science and Technology, NIHERST, and their program offerings, you can email marketing@nihirst.gov.tt. Feedback is also extremely important to improving and finding out areas that can be fleshed out some more or influence topics for the future. And so a post-event survey will be sent. I believe it will be placed in the chat. It will also be sent via email at the same email address, marketing@nihirst.gov.tt. All right, so at this point, I think we've come to the official closure of our event today. And on behalf of NIHERST and the APETT team, please allow me to once again express my sincere thanks to all for taking the time out of your schedules to participate in this evening's information session. remain poised for future initiatives, one of them, of course, being the upcoming virtual honors and award ceremony that's taking place on the 4th of February at 6 p.m. So stay tuned to NIHERST and APETT social media pages for more. We also wish to acknowledge some people who really went above and beyond to make this event a success. I'll just recognize them very quickly. Mrs. Marlene Lord-Lewis, NIHERST President, Dr. Chris Mirage, APETT President, the event organizers, Candice Hector, the marketing and communications manager of NIHERST, and her team, Mr. Rayad Mayru, the chair of the chemical division of APETT, as well as all members of the chemical division there. Ezekiel York, the public relations officer of APETT, the sponsor, can't forget the sponsors, Phoenix Spark Gas Processors Limited, for making this happen, and of course, to our panelists. Thank you again. Thank you for having me as your moderator. And do remember to continue the drive towards finding solutions to our engineering challenges. Have a great night, everyone.
Thank you.